In this video, I'm going to conduct a single sample mean z-test using JASP. I have JASP version 0.14.1. If you have a different version of JASP, the options or output may look slightly different. If you have any questions, please post them to the discussion board in Canvas along with a screenshot of what you're seeing. For this example, I'm going to use the student survey short file. The research question I'll be addressing is the mean SAT math score of students from this college different from the national average of 500? In the population, SAT math scores are normally distributed with a mean of 500 and standard deviation of 100. This is going to be a two-tailed test because we want to know if there's evidence of a difference. Our null hypothesis is that mu equals 500. And our alternative hypothesis is that mu does not equal 500. Because I know that the population is normally distributed, and because I know the population standard deviation, I can conduct a single sample mean z-test here. The single sample mean z-test is not used often, so in JASP, you'll actually find it under t-tests, under one sample t-test. There's a warning message here about a known bug in this particular version of JASP. When we compute the effect size, JASP will ignore our test value and use 0 instead. So if you need Cohen's d for a single sample test, double check that the value in your output is correct. Depending on the version of JASP that you have, you may or may not need to compute Cohen's d by hand. To get the single sample mean z-test output, I'm going to move my dependent variable of math SAT to the variables box. The default is student, which is a t-test. We don't want a t-test, so we'll uncheck that box. We want a z-test. The test value is the number from the research question and the hypothesis statements. In this case, 500. And the standard deviation is the known population standard deviation, which is 100. The default alternative hypothesis is two-tailed. Now, in our output, we have the z-test statistic and the p-value. Under additional statistics, we have a few extra options. Location estimate will add the sample mean to our output. Confidence interval will add the 95% confidence interval for the mean. Effect size will add Cohen's d, but note that in this case, Cohen's d is incorrect. This is showing the sample mean divided by the standard deviation, so it's not taking into account the test value of 500. If we check descriptives, we'll get a second table with the sample size, mean, standard deviation, and standard error. The options below we will not be using in this course.